Good morning, students. Hope all of you are doing well. Today, I'm going to start the new chapter number 2, motion. So, students, the rest and motion, these two words we are commonly used in our day to day life. But what is actually motion and what is actually the rest? That things today we will learn. So, suppose you are traveling by a car. So you are traveling by a car. So what is your motion? What about you? So you are in motion. But when you compare the others object, like when you are traveling by a car, that time if you see the outside of the car, then you can see some lamppost, houses, shops, etc. That time if I ask you what is that position of the lamppost or houses and shops, are they are in motion? No, they are they are not in a motion, they are in rest. So but you are traveling, so that's why you are in motion, but that other object with respect to you, the other objects like the house, shops, they are in rest. Okay, so what is actually the definition of motion and rest? That's things today we will learn. Okay, so let's see. So see here, student. For example, trees, houses, and electric poles are said to be at rest, whereas cars, buses, and other vehicles moving on the road are said to be in motion. How do we know this? This is by our everyday experience. So, according to our experience, we can say that trees, houses, electric poles, they are in rest position, and the others like the vehicles, cars, so those buses are in motion. So, the trees, houses, etc. never move on their own, because if you want to move the, if you suppose that book is on the table, so that book, the position of the book is in rest position, that book cannot move by itself. Okay, so that's why if you want to move it, then that position will change, then we can say that the book is in motion. But when the book is placed on the table, that time we can say that the book is in rest. So that trees, houses, etc. never move on their own, whereas any vehicle can move. So that's why the vehicle is in motion, or you can say that a vehicle or that cars, buses are said to be in motion. However, when you are traveling by a car, you see the trees rushing past by you. This means that for you, the trees are in motion, whereas you are at rest. So how would you decide whether an object is at rest or in motion? So see these students, when you are traveling by a car, you see the trees rushing past by you. This means that for you, the trees are in motion, whereas you are at rest. But you see one thing, when you are traveling by a car, if you look outside the window of your car, you will notice that you are in motion in relation to light post, houses, shops, trees, etc. Because their position is no change. But your position is changing. So that's why, this is because your position is changing with respect to these things, means the light post, houses, and shops. So that's why we can say that you are in motion and the other things are in rest. So that is actually how can you find out and how can you decide whether an object is at rest or in motion. So let us find out. So at first we have to know what is the definition of rest and what is the definition of motion. So a body is said to be at rest if its position with respect to a fixed point or an object in its surroundings do not change with time. So you see here, in this picture you see, this the first picture you see, that that car is below, under the tree. See, the car is under the tree. So you see this, in this position, that tree is in fixed position, that the tree cannot move, and the car is in under the tree and it is not moving. So that's why we can say that both are in rest position. So if we consider tree as a fixed point, so according with respect to tree, we can say that the car is at rest position. Yes or no? Because you see this in definition, a body is said to be at rest if its position with respect to a fixed point. So if we consider tree as a fixed point, so with respect to tree we can say that car is not moving, so that position is car's position is in rest, or an object in its surrounding do not change with time. So is surrounding this car that with respect to time is not changing. So that's why we can say that a car is at rest position. But you see this here, that car is moving. See, this car is moving. So here you see that the tree is in fixed point. You see that whatever that in previous picture, in this picture the place of the tree, and the second picture the place of the tree, both are in same position. But you see that that car is displaced some place. Okay, so that position of the car is displaced. So we can say that a car is in motion. Okay, so you see this figure, first figure, the car does not change its position with respect to the tree with time, but so the car is said to be at rest with respect to the tree. So here we consider tree as a fixed point. But on the other hand, you see that the car in figure 2 has has changed its position with respect to the tree with time. So the car is said to be in motion with respect to the tree. Okay, so that this is the difference. You see this in this picture, you can understand. So when the car is at rest position and when the car is in motion. Okay, so this is the definition of a body is said to be at rest. Okay, next you see that what is when we say that body is in motion. So hence a body is said to be in motion if its position with respect to a fixed point or an object in its surroundings keep changing with time. Okay, so we can say that a sofa kept in a room or a book laying on a table are at rest position as long as their position do not change. So if I keep the book on the table, then if you do not touch it, it is possible to that a book can move from one place to another place. It is not possible. But when you take the book and change its position, then we can say that with respect to the fixed point. So if we consider table is a fixed point, so that time that book can change its place. So that's we can say that book is in motion. So we can say that a sofa kept in a room or a book laying on a table are at rest as long as their position do not change with respect to a fixed point in their surroundings with time. On the other hand, a football kicked on by a player, the hands of a clock or a bird flying in the sky are in motion. So you see here, when the book a book kept on a table, so that book position of the book is in rest as long as their position do not, as long as its position do not change with respect to a fixed point or in their surroundings with time. But you see there, when a bar is flying in the sky, that time we can say that the bar is in motion. Or any clock, you know that hour hand, minute hand and second hand, they are always with respect to time is changing its position of hour hand, minute hand and second hand. So that's why we can say that hands of a clock is in motion. Okay, and the football, when a football, suppose if you take a football and you keep that football on the field without kicking, so that time we can say that the football is in rest position. But when the football is kicked by a player, then we can say that the football is in motion. Okay, because all its motion is changing with respect to a fixed point in the surrounding with time. So with respect to time and with respect to the fixed point, that position is changing with time. Okay, so time to time is changing its position, so that's why we can say that those things is in motion, and whose position is keep not changing with respect to a fixed point on their surroundings with time. That time we can say that our body is in rest. Okay, that is the difference between rest and in motion. Okay, so when we can say that body is every times when if they change their position, and we can say with respect to time, we can say that all those things is in motion. So when we can say that motion is relative. So when you travel in a bus, your body also moves in the same direction and at the same speed as that of the bus. However, you do not feel that your body is moving during the journey. It appears so because your body does not change its position with respect to the seat you are sitting on, or with respect to the other fixed one in the bus with time. So is that time we can say that your body is in motion. So let's see what we will say. But if you look outside the bus, you can see that the position of your body keeps changing with respect to the objects such as the trees. So when you are traveling in a bus, so with respect to seat or the handles of the bus, that time we cannot say that your body is in motion, because you that those things also they are also changing their positions, because the seat and the handles, all things are is in motion. So when we compare that seats and with the handles with you, that time we cannot say that you are in motion. Okay, with respect to that, so we are in rest. But when you compare the outside lamp post, houses, shops, trees, that time you see that they are in a fixed place. Means they are not changing their place with time, but your body is changing with time. So but you look outside the bus, you can see that the position of your body keeps changing with respect to the objects such as the trees and houses by side of the road. This shows that your body is in motion with respect to the trees and other fixed objects outside the bus. This shows that motion is relative. Okay, so when two bodies are in motion, the change of position of the of one body with respect to the other depends on the two factors, their speeds and their direction of motion. So that is actually the motion is relative. Okay, so when we say that is actually depend on that which objects we can compare. That is actually the matter. Okay, here, so actually that if you that your when you are travel in a bus, so that time that other person sitting inside that bus and the driver also, that time you will find out your position is not changing. Thus, you are at rest in relation to a certain set of objects and moving in relation to the other set of objects. Means when you see outside of the car, that time you can find out that trees, houses, shops, they are in their actual position. Means their position is not changing with time. So that's why that's certain sets of objects, when you relate with that time you can find out you are in motion. And when you compare with that inside of the bus, means driver and the other passengers, so that time you can find out you are at rest in relation to those set of objects. Okay, this implies that rest and motion are relative terms. Okay, so that is actually the main things. And when two bodies are in motion, the change of position of one body with respect to the other depends on the two factors. So what is these two factors? The first one is their speeds and their direction of motion. Okay, let's see the types of motion. So you see here there are many types of motions are categorized below. So there are different ways in which object can move. For example, ripe fruits fall straight down onto the ground. Wheels rotate, swing, saw to and fro, and marbles roll and mosquitoes fly in an irregular manner. The different types so you see here that all things are is in motion. So but that what kind of motion are those? So marbles rolls or mosquitoes fly and the wheels rotate, so and ripe fruits fall straight down onto the ground. So what types of motion? So they are not the same categories of motion. There are different categories. So types of motion are categorized below. So what is the first one is our translatory motion. So what is translatory motion? So if an object moves in such a way that every part of the object moves through the same distance in the same time travel, then the object is said to be in translatory object. Okay. So what is that? So if an object as a whole moves in such a way that every point on the object moves through the same distance in given time. Okay, so you see here every part or every point. So you see in this picture, you see that object. If you consider that 3 points, then you see that after that as a whole moves in such a way that every point on the object moves through the same distance in given time. So after a certain time, you can find out that when this object will move, then also the 3 point of this object also move. So means the whole parts of this object moves through the same distance. Means that this point to this point's distance and this point to this point is the same distance they will cover, and in the same interval of time. That time we can say that object is said to be in translatory motion. In simple words, the whole object moves at the same time and in the same direction. So that whole object will move in the same direction in the same time. At the same time, that whole object will move in the same direction and same distance will cover. Okay. So next is our the translatory motion are of two types. One is the rectilinear motion and another one is curvilinear motion. So what is rectilinear motion? An object moving along a straight line path is said to be have rectilinear motion. So student, here you see that beginning of that types of motion, that ripe fruits fall straight down onto the ground. So you see here, so do you think is that what type of motion is that? you do not think that is a rectilinear motion, because you see that in definition you see an object moving along a straight line path is said to be have rectilinear motion. So thus a car moving on a straight road, that is also the example of a rectilinear motion. Snooker ball moving in a straight line on being hit are in rectilinear motion, and an apple falling from a tree is also an example of rectilinear motion. So you see here, a snooker ball on being hit undergoes rectilinear motion. You see this, how this ball will hit this. So this what type of path that ball will cover is a straight line path. So that's why it is a rectilinear motion. But you see this curvilinear. So in that what you see this curvilinear, so means this actually that what type of motion it will be. So that object moving on a, this is a straight line path, that object moving along a straight line path, but it will be a curved line path. Okay, so a object moving on a curved path is said to have a curvilinear motion. Thus a cyclist racing on the curved track on a velodrome is in curvilinear motion. And the earth moving around the sun, a car taking a turn on the road, a ball thrown upwards at an angle, and throwing on a javelin are some more examples of curvilinear motion. So that you see this earth, the motion of the earth around the sun, you see. So the actually that what is this path is a curve. So the path is not a straight path, this is a curved, so that's why it is a curvilinear motion. Okay, this is an example of a curvilinear motion. So next one is circular motion. So circular motion is another type one. Circular motion is a special case of curvilinear motion. So sometimes it will be curve and sometimes it will be circle. So that's why it is a special case of a curvilinear motion, where the object moves around a fixed point in a circular closed path. In this case, the distance of the object from the fixed point always remains the same. So you see here, in this case you see this, if you consider sun as a point, then you see the here to here this distance and here to here this distance is same, but here to here this system is, this is a longer path, but this is a shorter path. So this path actually the shorter one, so this path actually the shorter one, and this is the longer one. But in case of a circular motion, if you consider this is a point, then here to here this distance any if you consider any point on this path, then from the center point to the given point on the path, that is the same distance. If you take a any point on the path, then that from the center the distance will be same. In this case, the distance of the object from the fixed point always remains the same. The motion of a child sitting on a merry-go-round on a giant wheel and reeling around of a hammer tied to a chain before throwing it are examples of circular motion. So merry-go-round, I think all you know what is this. So this is what is looks like. This looks like a circular, and the motion of a merry-go is a circular motion. So this is a example of a circular motion. Next one is that, so this is actually that this rectilinear motion, curvilinear motion, circular motion, they all are in translatory motion. But translatory motion are actually the two types, rectilinear motion and curvilinear motion, and circular motion is a special case of a curvilinear motion. Circular motion is a special case of a curvilinear motion. Okay, so next type of motion is the rotatory motion. What is the rotatory motion? So when an object rotates or spins about an axis called the axis of rotation. So you see here, this what is this? I think these things all if you know. So if you throw on this floor, what you will say, these things will in on this point of these things, it will rotate. Okay, so that in rotatory motion all the parts of the object do not move through the same distance in the same interval of time. The part away from the axis moves through a greater distance than the part near the axis. Okay, so the wheel of a moving car, a moving fan is spinning tap top, the motion of a potter's wheel and the motion of the hands of a clock are some examples of rotatory motion. So these are the example of a rotatory motion. So now is the oscillatory motion. So when an object as a whole moves to and fro about its mean position, it is said to be an oscillatory motion. Mean position is the position when the object is at rest. A swing in motion and a swing pendulum of a clock. So pendulum of a wall clock you have seen. So when that pendulum is in middle position, so that means that is its mean position. So means that is its rest position. So then that pendulum will moves to and fro, and that's why it is actually oscillatory motion. So when an object as a whole moves to and fro about its mean position, it is said to be an in oscillatory motion. So next is this vibratory motion. If the whole body does not move to and fro as a single unit, but some of its parts oscillate about their mean positions, it is known as vibratory motion. Vibratory motion is an effect of oscillatory motion of some parts of an object. Thus, vibratory motion is a special case of an oscillatory motion. Oscillatory motion, the whole moves to and fro, but here actually that the whole body does not move in vibratory motion. Only that single unit does not move to and fro as a single unit, but some of the parts oscillate about their mean position. Only this part, the motion of the prongs of a tuning fork is an example of a vibratory motion. So only these two hands actually they can these two parts is oscillates about their mean position, but these parts cannot move. Okay. So vibratory motion is an effect of oscillatory motion of some parts of an object. Thus, vibratory motion is a special case of oscillatory motion. The motion of the strings of a guitar when plucked on the motion of the prongs of a tuning fork when hit are examples of vibratory motion. So hope student you understand. So today we learn what is motion and what is rest, what is types of motion, translatory, rotatory, oscillatory. Next day I will start from the repetitive motion. Okay, so up to this you please learn and read properly, and because that examples in this part is very important. Suppose the examples is given, you have to find out which type of motion is it, or the motion is given, you have to write down that write the example on that motion. Suppose write one example for vibratory motion, write one example for oscillatory motion, or write one example for curvilinear motion. So those kinds of question will come. So please read, and next day I will start from repetitive motion onwards. Okay, so thank you students, hope you understand. Bye, take care, goodbye, have a good day.